talk about the difference of two squares. And so this is a factoring pattern. And so whenever you have two terms, this is what you're going to look to do. Okay, now notice what it says, difference. Difference means what? Subtraction. So that means this doesn't work for addition. It only works for subtraction. So if you have addition, you can't factor this way. Okay, so that's important to understand. And squares, if you notice here I have a squared. So any number or anything squared minus anything squared. So they have an example here. X squared. Well, that's x squared. Okay, 25 is what squared? 5. So how we factor that is we take whatever was the first term, okay, that was squared, in this case x, whatever the last term is that's squared, which in this case is 5, I put 1 plus, 1 minus, and that's my answer. Okay. Now notice I could write it the other way. I could put a minus first and a plus second. Doesn't matter, just as long as one is minus, one is plus. Okay, it'll also work, in this case, t squared minus 64. T is our first term squared, 8 is our second term squared, 1 is plus, 1 is minus. Now in order to kind of think about the difference of two squares, we're going to actually list the first 15 perfect squares. Okay. So I know that 1 here is 1 squared, right? What is 4? 2 squared. So then we have
3 squared, 4 squared, 5 squared.
So what'll go here in the box?
6 squared.
Actually on the line.
Oh,
36.
Oh, guys.
Okay, what'll go next? Next.
64.
64.
I just want to know, before you have this baby, are we ready for the NISA?
Okay, so what's after 64?
81.
81.
100.
And then 100. We'll see how well you do after, on the next one.
121.
121.
144.
144.
169.
Yeah.
169.
196.
196. One of the things about these is they actually flip-flop. And then 15 squared is 225. Now, it's kind of important at least that you know the first 12. These other three, okay, are kind of some ones that you should kind of familiarize yourself with. Eventually, when you get to algebra, you should know the first 20. Okay? So, anyway, those are the first 15. So let's go ahead and look at an example. It says factor each polynomial. And so I have 16h squared minus 9a squared. So let's think back to the very first step that we talked about yesterday and the days before. We have to take out something that's in common, if we can. Is there anything in common on those?
No.
No, so then I have to look at the numbers that I'm given. I've got a 16 and I got a 9. So automatically I should be thinking, hey, those were on the list. I've got a subtraction sign, so this might be the difference of two squares. What is squared to give me 16?
4.
What is squared to give me h squared? H. Okay. What about 9? 3. What about a squared? So those are my two quantities. And so now all I'm going to do is I've got two sets of parentheses. What will the first term in those parentheses be? 4h. What will the last term in those parentheses be? 3a. So see, that's why I wrote those there. And then I know that one is minus and one is
Plus.
there you go. And that's it. Okay. Now we're going to have a ton of examples today. So let's look at this next one.
Wait, that's it?
That's it.
That makes me feel so much better.
Okay, so now I have 121 and 4. Is something in common with 121 and 4?
Yes.
121 and 4? I can't take anything out, right? Nothing's in common there. But what do I know about 121? It's 11 squared. What about 4k squared? 2k.
Okay.
So once again, two quantities. First term in each quantity? 11. Last term in each quantity, 2k. 1 is,
Addition.
1 is.
Subtraction.
So notice, we put the plus first on the second one, the minus on the second term. It doesn't matter, as long as you have one of each. All right, 27g cubed minus 3g.
3 goes in
3, anything else?
G.
A G. So I notice there's a 3g, so I'm going to factor those two terms out. So 3 times what gives me 27? 9. G times what gives me g cubed? G squared. 3 times what gives me 3? 1. Okay, remember we never put 0. Okay, we always have to use 1 as that placeholder. So then now let's go ahead and look inside the parentheses. What do I know about the numbers 9 and 1? They're squares. What is squared to give me 9? 3. What's squared to give me g squared? G. What is squared to give me 1? 1. So first of all, I've still got the 3g out front. For those of you wondering where that came from, that's the first 3g I took out. Okay, now I got two quantities. First term in each quantity, 3g. Next term in each quantity, 1. 1 is? Plus 1 is? There you go. Okay, real quick, I want you to do that bottom one for me. Okay, real quick, I want you to do that bottom one. Okay, so real quick, you should have had 9 plus c times 9 minus c. Okay?
Does it matter if you have plus or minus?
No, it doesn't matter. Yep.
Is it alright? I put a 1 before the C.
Yeah, but you don't need it. Yeah, so. Okay, so let's go ahead and look at this one. Negative 4y cubed plus 9y. Negative 4y cubed plus 9y. Anything in common? There's a y. Okay, but if I look at it, I've got that negative sign out front that's kind of in the way. So what I'm going to do is I'm actually going to rewrite the problem. Now generally we usually like to have our highest power first, okay, but this has two terms. And so it's one of those in which I'm kind of thinking ahead, I'm looking, I see a 9 and a 4, I know those are perfect squares. So I'm kind of trying to get it in the form that I can factor it. So I'm going to go ahead and take out a y. And when I do that, what am I left with?
9 4y squared.
Good. So what is squared to give me 9? What about 4y squared? 2y. So I have y, and then I have two quantities. What will be in each of those quantities? 3 minus 2y and 3 plus 2y. There you go. Alrighty, the bottom one, 625 minus x to the 4th. Is 625 a perfect square, yes or no?
Yeah, 25.
25, okay. So we get 25 and x to the what power? Squared. Okay, so real quick, if you're wondering, how would you determine what it is? You take your exponent and you divide it by 2. That'll always tell you what power you use. So like up here when you had a 9y or a 4y squared, 2 divided by 2 is 1. Okay, so just take your exponent divided by 2. So what are my two quantities going to be?
25
25 what?
minus x squared.
Okay, and
25 plus x
and I'm done, right?
squared.
Why am I not done?
They're still perfect squares.
Ah, they're still perfect squares. Okay, what is squared to give me 25? X squared. X. Now, do I do anything with this one right here? No, why not? Because it's addition. We only mess with the subtraction.
Why?
Okay, so This first bunch, I'll get 5 plus x, 5 minus x, correct? And that takes care of the 25 minus x squared. What do I now need to add to my answer?
25 plus x.
25 plus x squared.
Well, why do you leave 25?
Because it's addition, it's not the difference of two squares. So it only works with the difference. Okay? Alrighty, here you go. I want you to try this one for me. 16n to the 4th minus 1. Okay, so up there on the board is the solution. If you just had what was in purple up there on the top, you neglected the fact that 4 and 1 are both perfect squares as well. Okay, you needed to actually do the difference of squares twice on that one.
Doesn't have to be more like that.
So no, it doesn't have to be in order like that. As long as you have this term somewhere, this term somewhere, and this term somewhere, okay, that's all you need. Now those are the only 3 terms you can have though, okay, but they can be in any order. Any other questions? Okay, so now we're going to look at another one. We've got about 3 more types of problems, and these aren't all going to be difference of squares. What do you notice about this one? 5 goes into both. Anything else? An x. So I get 5x. What will that leave me with? X to the 4th minus 9. So is x to the 4th a perfect square?
Yes.
What is it?
X squared.
What about 9? 3. So I've got my 5x still out front, and then I've got my 2 quantities. What will be in the first quantity?
X squared minus 3.
X squared minus 3 and
X squared plus 3.
x squared plus 3. Am I done?
No.
Well, you can't,
Yes.
3 isn't a perfect square.
3 is not a perfect square, so am I done?
Yes.
Yes. Okay. Only if it's a perfect square can you factor that. Alrighty, 4 terms. Okay, 7x cubed minus 21x squared minus 7x plus 21. Okay, first things first. We always have to take what's in. 7 goes into all of them, so let's factor that out. So if I take a 7 out, what do I get? X cubed minus
3 x squared minus x plus 3.
Now I've got 4 terms, so do we remember what we do with 4 terms? You
Couples.
pair them up, you make them into couples. So here we go. There's our first couple, there's our second couple. Okay, so I've still got that 7 out front. Remember, we just leave that 7 there. What can I take out from the first couple? X squared, and then that leaves me with x minus 3. What can I take out from the second couple? Be careful. Negative 1. Why does it have to be a negative 1? So the x's match up, and so I have an x minus 3. Okay. So then now, I've got my 7. What will be one of the factors? X minus 3, because that's the one that's in common with each of these. What's the other factor? X squared minus 1. So I'm done. Right?
Nope.
No. Why am I not done?
X squared.
The x squared minus 1. Okay, what will this factor down to be? X, what?
X minus 1.
Minus 1 and
X plus 1.
x plus 1. So you always have to be watching. Okay. You always have to be watching to see if you can factor those down anymore. We have one more today. Okay, I know we've got a ton of examples for today. I want you to go ahead and try to do this one for me. Okay, you try to do this one for me. Okay, up there on the board is the solution you should have gotten. Okay, you might have forgotten to take down the m squared minus 25 one additional step. Okay, but the answer should be in blue. Okay? So you're gonna have to kind of keep your eyes open for that. Now remember on Monday, section 8-7 will be turned in. Okay, here's your section 8-8 assignment, 15 through 43 on page 519. Now you're probably gonna be spending another day on 8-8 on Monday with the worksheet. Your test is going to be next Friday. Okay, next Friday will be your test in this class.